Yes. Hey, welcome on my behalf and Lyti's behalf as well. I'm Lauri, working as a CTO in Lyyti. You are at our headquarters in Turku Centrum. Lyyti is a product company. We help people to do meaningful encounters. So basically we do event management or event success management application. We are a company of 70 people, 25 working in product development and operations side. We have offices here in Turku and then one office in Stockholm and one in Paris. We are growing and recruiting, so if you happen to be interested, we will be publishing especially QA, front-end, and design-related jobs pretty soon in the upcoming months. So if you're interested, check and apply. And if you're really wanting to join, you can discuss with Lyyti people here. We have the hoodies, so you know who to talk with. That's the short intro and advert. Then few practicalities. There's beer and other drinks at the fridges on the tabletop. Go ahead, enjoy yourself with the drinks. The food arrived and will be shared after the first speech, so food is available pretty soon. And toilets, they are there on that side, 4 of them. There are some closed doors at the office. They are restricted areas, so don't go there. They are closed. All other areas are free to roam, and you can check our office and meeting rooms as well. So, welcome, enjoy the evening, and then I guess it's Dusan next with the first speech.
Oh, okay, all right, let's deal with that first. All right, there we go. Reshare the screen, entire screen. There we go. All right, so can everyone hear me well? I have to like be slightly hunched over like this. All right, so hello. All right, so it's a bit too fast already. Starting off well. What the heck? All right, there we go. All right, so Hypermedia. Oh, Hypermedia as the engine of application state. That's what I'll be talking about today. So before I get into that, let me talk a bit about myself. So, hi, my name is Dusan Turajlic. Some of you know me. I'm a senior software developer here at Lyyti. Started about 9-ish months ago. I'm also one of the founders of Turku Forge, which is an open source organization here in Turku. Please check us out. We do cool things. I'm a dog person, and that's a picture of my dog. He is extremely cute, so thumbs up for him. I'm also a quadcopter enthusiast, which is probably the nerdiest thing about me, because they're these little like tiny drones that have a camera on the front, and you fly around with them, and you have goggles on your face, and you look really weird, but it's extremely fun. So if we get into the meat and potatoes of this presentation, so the reason I wanted to have this talk is kind of to tell a bit about Hypermedia as the engine of application state, because I don't think that many people know about it or have worked with it or anything like that. So by a quick raise of hands, who here has worked with or heard of Hypermedia as the engine of application state? Oh, actually quite a lot of people. Quite a lot of people, so better get this right then. All right, so yeah, so the thing I'm gonna start with talking about is what Hypermedia is in itself, then kind of what is HAL, and then a short demo of kind of it in use and practice. And then finally, hopefully people will have questions. So what is the H in HATEOAS? So that is Hypermedia. And if you Google the definition of Hypermedia, you will get Hypermedia, an extension of the term hypertext, is a non-linear medium of information that includes graphics, audio, video, plain text, and hyperlinks. Now that clearly explains exactly what it is, right? I like to think of it like this. So it lets you see beyond the scope of your current document, basically. And the simplest way of doing that is with links. So if you think of, for instance, an HTML page. So you request something from a server, you get back an HTML page, and you get the link. You get a link in there, which this link is specifically to a CSS file. And this link kind of tells you a lot about it. It tells you the relation, which is the style sheet. It tells you what the media type will be, and it tells you where to get the file from. So when a browser gets an HTML page, it can parse this and get a file quite simply without the need to do any extra things. The document describes what it needs to do. That's one part of Hypermedia. The second part is the related resources. So this is a bit more of a complex thing. But it's almost the same. If we go first to the links, it's basically the same thing as we see here. So it's also a link. The relation here is the self, and the href is still the href. And the embedded is actually something that is kind of interesting because it's kind of similar to if you worked with databases and ORMs, they have this feature called eager loading, which this is the same thing, except the API kind of eager loads data that it knows you need for this resource. So for instance, in this example, we have embedded, which is the related resources. Here we have, well, this is just the settings of this user. So this user basically has, well, all we know about this user right now is that they have 2FA enabled, and their name is John Doe, and their email. But that's basically what we get right out of the box from Hypermedia. It just tells you what links you have and kind of what related resources you have. That's Hypermedia, and this response is actually in a format called HAL, which it's just a format. So, and HAL means Hypermedia Application Language. All of these acronyms are extremely bad, but they work. So yeah, so it has a lot of internal features on its own, which I'll try not to go too deeply into, but they are really handy. Additionally here, like if we look at the self link, it is actually relevant kind of what the relation is, because there are these things called IANA link relations, which also can't go deeply into them, but they are essentially this predefined list of basically explanations of what a resource is, for instance. So self being the current resource you are right now, there is a whole document describing IANA link relations that describe what terms of the IANA link relations and when to use them and what they're useful for. And the second one in the embedded, this is actually a CURI, a query, which again, really simple, but essentially it's a compact uniform resource identifier, if I remember the abbreviation for that correctly. But basically that can be used with HAL to basically deliver API documentation about this specific like compact URL directly. But that is HAL related. But also all this to this point we've talked about Hypermedia, which in itself is static. So if we look at HATEOAS, which is Hypermedia as the engine of application state, that is dynamic. So you get in this dynamic feature of it. What I mean by that is that basically anything inside the embedded, anything inside the links, and the links themselves and the embedded themselves, you can assume that they're there because they can and will change. That is kind of the beauty of this, that they change and they allow you to basically tell the client that's consuming your API what they can and can't do straight just from the response. You no longer need to duplicate logic between the front and the back end to basically figure out how this should connect together, what API endpoints should I connect to get this working, what API points I even have access to get this working. The API can deliver this to you. So if we, the best way I figured out to show an example of this is a simple application. So I made this beautiful flowchart, used FigJam for the first time, which was cool. So here we have a simple application. Start by you go shopping. You can add items to cart. If you're done, you can go to your orders. You can pay for your orders, and you can, your order has been placed then. You can also add many items, and you can cancel your orders and completely delete them. So if we look at that, I already built an API for this. Thought it wouldn't be fun to watch me like do that live and struggle with Spring Boot. So I built it like yesterday, and this I'm going to demonstrate this using the Hell browser. So the Hell browser looks very intimidating when you look at it like this, but it really isn't, because it's divided into two sections: the Explorer and the Inspector. Inspector is basically just the HTTP headers and the response body. So, and it's all nicely formatted, so you can really easily debug this. But on this side where you have the Explorer, you can actually see the links that you have access to. You can also see the properties, but this response does not have any properties, but I'll show you a response that does. So here we have basically the same links, and we have them here as well. So we have the self, same as here, there's a self. Then we have the DM product, which is again the query I was talking about. And then we have the DM order. So when I get this response from the API, I already know this is all I have access to. I can't do any more than this. So by knowing how this API is implemented, I can go check out products and be like, oh, okay, so here are all my products. I have 5 products, and I can make an order to these products. So because I know how the API works, all I need to do is grab the ID, and then all I need to do is post into the API. And boom, an order has been, or this has been added to my order, the ID. So that's really handy. Now I have that there. But when I go back to the entry point, now something happened. Now I'm no longer the same user I was before this. Or I mean, I still am the same user, but properties about me has changed. I have now made an order, which means I now have access to canceling, I have access to pay for things, and I have access to, well, still access to the order and the product. But I can also get like order and see what I have there. I could do that before as well, but I can do that now too. So now I have this, and in this situation, I already know what actions I have. I even can see what items I have ordered, and I can even pay for them. So I can go check out my payment options. I can pay for this item. I can do all of these things. But for humor's sake, we're just going to cancel this, and because, well, this cancellation is going to be a delete, so like that. Now I deleted my items, and now if I go back to my entry point, I'm back where I started, because I no longer have items there. So I can't actually make any purchases. So I can't make a purchase or cancel any purchase. And that kind of handy thing with HATEOAS that it kind of tells you access to and what you're doing. Now I did build a UI for this, and it's simply this. Purely products only developers would buy. So there's a Live Laugh Code coffee cup, which doesn't even say that. Then there's the ironic t-shirts, laptop stickers, mechanical keyboard, and a book on how to exit Vim the right way, which is the only thing everyone really needs. So this basically does the same thing as my API over here. I can add to cart, and then here I now actually listen show that again. So if I add to cart, I now one item into my cart, I get my payment options, and I'm able to cancel it. So this is really handy in the sense that I can just basically pick this item, it's ready. So I just basically pay with a credit card, and now I have a fully ordered item. I can't do anything else. And as you can see in our chart, we don't have the ability to cancel an order once it's been made. So after you've paid for an order, you can't cancel it anymore, which made sense at the time when we developed this. But there came a new business requirement, and we now have to be able to cancel orders. And you're sitting there with your whole team, you're like, oh, damn it. We already implemented this in our Android app. We did this in the front-end app. We moved all these things around, and now we have to like do a whole implementation for adding this one freaking cancellation button. But you're different, because you're like, hey, we use HATEOAS for this. So you're like, hey, what if we just do this? Like that. Now we wait for Spring to, or actually we wait for the compilation to finish, and then for, I moved this, sorry, so I moved this media link that links the other controller and has the relation of cancel. I moved that outside of the if statement that says shopping service order is still pending payment. So I moved that out of there, which now basically made it so that the cancel link is given to the user or to the consumer of the API, even though the order is finished. So now if we go back here, we now no longer orders because I only use the in-memory database. So once it rebuilt, all my data was gone. But now if we do this again, so if we add an item to here and we pay for it, now we have the cancel link here. And I didn't change any front-end code. It just works because my front-end code was built to anticipate this. Well, of course it was for this presentation, but it should be like that always. So the front-end code was always just checking, is this link relation present? Yes?
So the line you move, that is basically the change in the diagram. So the code there that outlines the diagram.
Yeah, sort of, basically. They can't hear him, can they? So he asked if the code I moved changed the basically changed the business logic so they would follow the diagram. And yes, that's basically what it did. Now, of course, I do have the ability to cancel it, and it's fully gone. So now we can even cancel paid orders. There was no mechanism for actually refunding the customer, but besides the point. So basically, that is kind of the beauty of HATEOAS. And if you ask yourself, why is this useful? Well, if you think of it like if you have purely a web application and basically no API, kind of isn't. You might as well just do server-side templating and do it that way. But most of us probably have mobile apps and other things like that that kind of require these kinds of fine-grained changes that happen quite frequently. And it's especially in mobile apps, this is a problem, or like a big problem, because when you release a mobile, or like when you build a mobile app, you build it assuming some things, and then you deploy it, it goes out to hundreds of users, and then a business change that comes in, and you're sitting there and thinking, damn, I really wish I would have thought of that when implementing this, but you didn't, and then you have to make the change, re-release your app, and then little Timmy on Android KitKat is still sitting there with the old version of your app and saying, why is the API just throwing me errors? Like, I don't get it. So that's kind of the beauty of HATEOAS. It allows you to kind of change like functional logic just by changing the API response. And if you, it is, but don't worry, it should be 10%. Yeah. Yuhi has asked if the battery was running out. It's like 10%. Be all good. What was I saying? Yeah, the Android apps. Yeah, so if you implement your client to basically not depend on any specific like fields from the response, just basically check are they there and kind of change your UI based on that, gives you quite a lot of benefit in the sense of what you can accomplish with just making trivial API changes. Also allows you to basically need to version your API less frequently. So for instance, in some cases, if you make an API change as trivial as changing an enum, you might need to upgrade to version 2 or version 5 of your API because, well, somebody who integrated has created a representation of this in their client, and now the JSON won't parse because you don't have that value there anymore. So things like that can happen, and this kind of allows you to like circumvent a lot of those situations. And this is also especially useful for, I need to ask, has anyone ever built an application with no access control whatsoever? A lot of hands down, which is good. So this is extremely useful, especially when it comes to like access control, because with basically different users, you can present them with different links, and you don't have to duplicate the logic on your client where you basically, either get the user, get their roles, get all the things that they have, and figure out the same logic that's already been done on the back end. You're figuring that out on the client again, which is completely useless. You could just use this and it would be way better. It is challenging to figure this out, and you really need to kind of know your API flow and the business logic and the whole domain logic and all of that. All that kind of needs to be figured out by the time you start doing this, because if you don't do that, you will most likely make some like educated guesses at the time, but then like a week later you're like, yeah, that was completely stupid. So there are like drawbacks, and it's quite hard to do these things, but it's doable. I promise you, it's doable. So, yeah, thank you for listening, and hopefully we have some questions. Yes.
It's kind of contradictory what you said. First you said, yeah, it's super flexible, and after the fact you change all the requirements and everything falls out, and then at the end you say, but you have to figure out all your requirements before.
Well, not all your requirements. Yeah, so the question was that it's contradictory to say that you have to figure everything out beforehand. That's basically that you can't just with HATEOAS basically give in new links. But the thing you kind of need to figure out is kind of where your starting point is. So how you enter into the API and all that, and kind of like where you go from there, what actions you have from there. And then you can add on more actions later on, but those like first actions are the ones that you kind of need to figure out.
Love to see like in the future you post somewhere a practical example of that.
This was a practical example. I got orders here. Yeah, it is quite abstract. Yes, Temo. I'm not, or actually yes I am, but the question was, am I running this instruction? Actually am. Turku Forge's API is fully HATEOAS based. No one's using it, but it's in production. But also, for instance, the last company I worked for, Hyperbox, their entire like API solution is HATEOAS based. Yes.
So how does this interact with like caching? I mean, if you have to modify response for like every user role and so on, you basically don't have any caching for
Yeah. So the question was, how does this interact with caching? That's a very good question, and it does. You can, it does. Yeah. I don't have a clear answer for you on how to do that, because I haven't needed to do that yet. But I know that it's doable because the last company I worked for did it. So I know it's doable. Yes.
How do you handle changes in, for example, the embedded names, the DM product, changes to DM products?
Oh well, that is. So how do you handle changes in relation names? So for instance, if my DM product changed to something else, that handle well, you kind of need to refactor that one. Like those are essentially, since they are the queries, the compact uniform resource identifiers. Since they are, then when you change those, you kind of need to, I don't know, either add the same old relation still be in there for a set period of time, and once you can guarantee that no one else is using that, you can just remove it.
So since it's Hypermedia, couldn't you do like a permanent redirect?
Well, it's a query. If you in your the question was Hypermedia, can't you do a permanent redirect? So the query is actually just this key identifier, which is basically what you use to figure out what the URL is at all. You can change the URL, like the URL under as much as you want, but the query is kind of the important one. That's the thing that identifies what resource this is. The resource can switch places and the path can change to anything, but the query kind of needs to be the same. And you, as I said, you can like just create the new one and keep the old one in for a period of time until you can guarantee that no one else is using that one. Then you just remove it. Any more questions? Yes. It's on GitHub. Yes, on my pro. That's the word I was looking for. Yes. Yeah, I mean, well, there are libraries that are being developed for it, and I guess the what's it called? The specification changes. I haven't checked in a while or at all, but probably it changes. I'm gonna ask my own question. So since Hypermedia is by nature very easy to like basically traverse through, you have this thing allows you to go through it and figure everything out. Is anyone here concerned about fuzzing? Fuzzing is the thing where basically a malicious actor, basically a script or a user, tries to figure out how to do weird stuff in your API. So this is something I actually thought of in advance to ask, because I know that this is something that might be of concern to someone. But one more thing that Hypermedia gives you is a entry point. So what you actually can do is, once the person requests the root of your API, you can actually change the URL and add like a encrypted token here at the end to kind of specify information about the person like requesting it. Basically the IP address, how many requests they made, what their previous request was, how many malicious like payments have they tried to make, those type of things. You can basically bake those things into an encrypted token and add that to the URL. And that basically allows, I mean, that makes it so that your endpoints can't be used at all unless they're used through your entry point. Oh, can't be used at all is a strong word. Somebody will figure it out, but still, it makes it a lot harder, and it actually gives you like a lot of benefit in that sense. But in case there were any like security concerns on HATEOAS, it is like as secure as any regular REST API. It is a REST API. But yeah, it's just as secure as anything else, because like all these endpoints underneath are just plain CRUD endpoints. And it died. All right, so that was it for me. If no more questions, then thank you very much.
So let's have a break. There's food. Yes, food and drinks. We'll start the next talk at 7. So we have like 15-20 minutes, if I read the clock correctly. Also for the live stream, we will continue at 7. So don't go anywhere. If you can all join within the sight of the talk. So the next talk, Matias, can you come back? So our next speaker is Matias Huhta, who's gonna talk about web components. So let's give a big hand to Matias.
Ooh, let's see. First time performing live in front of an audience, so let's see. Can everybody hear me? Is it coming through? Yeah. Perfect. So, web components. That's today's second subject. But before we get into the subject itself, a little bit about me. I'm Matias Huhta, as you just told everybody. I work at Simpler. We're a small software consultancy here in Turku, and we're like one of the 2 companies in Turku who work with web components. It says like us and Vaadin. There might be others, but they're not too vocal on the media, so I don't know about others. And we do some work with web components, but most of my experience with web components is from open source, and I've been doing those things for like almost 3 years for now. And the code examples I'm showing today are going to be linked to my GitHub, and if you want to talk more about web components, you can reach out to me in Twitter after this talk, or in Slack if you are in Code Clinic or Lyyti and Friends Slack. And some of the things I've done in web components, my maybe latest and greatest things is web components dev tools. This is a small shield to the start of the talk, but we're going to the meat soon. But web component dev tools, so I've created if you worked with React DevTools or Vue DevTools before, it's kind of the same, but for web components, because there's not a good tool for inspecting your components in the browser. So I just decided to make one, and it's almost at 1,000 users, so EP. And also I do some tooling around web components, mainly just like, well, not visual tools, but like routers and management systems and all kinds of stuff. And currently my main project is working in a Google project that is trying to make a code built solely around web components. It's called Playground Elements if everybody wants to check it out. And there are some web components people already using it, so let's hope it goes big. So what are web components? Some of you might have run into the word like before. It's been talked quite a lot, and the meaning has changed quite a lot during its lifetime. But the web components I'm here to talk about today are the custom element components, which are the browser API web components. So web components are built on top of the browser APIs provided by all of the major browsers, so Safari, Chromium, Firefox. Even the smaller ones are nowadays supporting them. And they'll allow you to create fully custom and reusable HTML tags. As you might see in the picture next to the slide. So it might look really similar to people who have worked with Vue, for example, and it might be similar to people who have worked with React, but the difference here is that it's completely built into the browser. The functionality is not from a library, but it's straight from the browser itself. And it's based on existing web standards, which kind of means that it's not going away anytime soon, because it's not a library, it's not a fad, and it's built into the standards, and it's approved by the standards committee, so it's being implemented into all of the browsers, whether you like it or not. And the best part about web components is that they're library and framework agnostic. So you can just go home today, create a web component and slap it into your React or Vue application, and Angular applications work, or if you have a static site hosted with Hugo or any static sites generator, you can just put them into those two without any kind of a hassle. And the reason I'm giving this talk today here is because web components are currently growing rapidly. One out of 5 page loads already is using web components on the web. So that's like 20% of all of web loads are using web components, whether you know it or not. Here's the statistics for that, just so you know I'm not talking out of my own bias here. And whether you know it or not, you're using web components every day, because companies like Google and Adobe are both using web components on most of their products today. Google has been using web components to create their UI for YouTube for, I don't know, like it's been Polymer web components for the last 5 years or so. They have been transitioning into them one component at a time, and you didn't even notice it because it's a tool that allows you to transition from a tech to another extremely quickly and without any hitch. And web component libraries are also growing at a rapid pace currently. There's a few which are maybe leading the race a little bit. There's LeadElement, which is a web component library provided by Google. And then there's Spectrum web components, which are by Adobe. And then there's Microsoft Fast Components. So a lot of big tech companies are currently adopting web components, and they are using them in a lot of their products, and they are adopting them into more of their products by the day. So why would you want to maybe use web components in your application? Well, the first thing is, as I said before, they're technology agnostic. So it doesn't matter if you have a React application, if you have a static application made with Elementy or anything, you can use web components anywhere you have a browser which you can slap them into. Web components don't even need a build system to work, so you can just write a component straight in the browser and it will show up there without any dependencies or any building steps. And because they're put into the web standards, they're pretty much here to stay. They're not going anywhere because web standards, they move quite slowly and they're not going to change anytime soon. So I think that's enough of a proof that they are here to stay. And I just can't stress this enough, that they work on any framework. So whether it's a React application to server-side render, or it's a Vue application completely on the browser with no backend, it's going to work there nonetheless. And they provide full encapsulation. So when you're creating, for example, component libraries or design systems with web components, they are pretty much plug and play. They provide full encapsulation for the styles and the DOM that they provide, and it can be modified by the outer services without explicitly telling them to modify it. And there's a site called Custom Elements Everywhere, showing the current status of all of the major JavaScript frameworks and how they support web components. I think that pretty much the only library that's currently not 100% supporting it is React, and that's to the way that React handles events. And they are working on it. They've been working on it for some time, but it's not a priority because there's also some libraries that fix this issue also. But yeah. And web components are great because instead of you having to design your systems like, okay, we're building from the ground up and we're going with this web components fad right now, and we're going all in on it. You don't need to really think about it like that. Web components are a technology that allows you to transition seamlessly from your old application to your new version, because they can be adapted into any framework you are using, and they can be used anywhere, almost anywhere. Server side is kind of iffy right now, but it's coming there. So they are a perfect transition tool for applications, and some of the proof that web components are a great way to go from one technology to other is, for example, GitHub. There's multiple web components being listed on the side with the tool that shows you that even on your everyday visit to GitHub, you are already being exposed to a large collection of web components. GitHub, as far as I know, writes them without a external library. They have their own internal library that they use to build them, but a lot of web component authors decide to use a one helper library or just go full vanilla. And if you're interested in seeing how GitHub does it, they're all completely open source, so you can just go ahead and check them out right now or after the talk. They're on GitHub's repositories, and they can be found with the web components or custom elements tag. And I think there's a myth, like if anybody has heard about web components, a big myth that's surrounded by that's surrounding web component is that it's not really ready for complete applications. So you might be thinking like, okay, yeah, I'll try the web components, but we actually need to create this app with React or Vue because it's not ready for complete applications. But if anybody read the web dev news yesterday, Photoshop is going on the browser and it's completely powered by web components. So big companies are already doing it, and if they can do it, so can you. And I even asked Westbrook, who is working at Adobe, and it starts with a classic wrapper for your app, and it's all the way down just web components. No like L11T to serve the content, or no React frame to frame the content for your components. It's all the way down just web components. And they are using a library called Lyyti, and they have built a web component design system or a web component library on top of Lyyti, which is a web component library that makes it quite a lot easier. And we are going to be showing a small demo about that soon. But first, let's see who else is using web components. There's quite a few big companies who are already investing into their web components. For example, you might see Salesforce has created a Lightning component with their own web component systems for years, and it's already being adopted by, well, Salesforce says 5 million developers, but I'm not the one who has the numbers, so I'm not going to say any static numbers for that. But you might see big companies like Blizzard, Google, Adobe, we went through, but EA and Nintendo are even using web components. Nintendo isn't listed here, but they are. You can just go into their page and see the source code, and you will see it there. So that's a nice information dump for anybody who didn't know what web components are. But you might be thinking like, how do you do them? How is the developer experience? How cumbersome is it to create these components that are completely like framework agnostic? Does it like come with a lot of pitfalls or anything? Well, before, like if somebody tried to create web components in like 2015 or 2014, around the era when they were like landing on the first browsers, Chrome, I think did first, they were quite cumbersome. There was a lot of boilerplate code. It was ugly to write it, and it was just hideous to maintain it. But nowadays, with libraries like Lyyti, which is powered by Google, you can make web components as easy as you would using any application framework like React. And today we are going to be starting a project and lab coding a small project here. And we are going to be using a OpenWC initializer to create it. OpenWC stands for Open Web Components. It's a group of people who are advocating for web components and who are creating guides, tools, and libraries to make it even easier to start getting started with this. And if you want to go home today and try web components but don't want to install anything on your computers, there's also webcomponents.dev, which is basically if you've ever used Code Sandbox or CodePen, it's the same thing, but for a web component, they have plenty of templates you can get started with. But let's get into the actual demo, and we can go through the whole process of building web components and how they work and what's so great about them. Let's see. It's opened, and as I showed you as I showed you in the material, we are going to use the initializer called OpenWC. Let's hope my internet is not going to break here. And the OpenWC scaffolder is really intuitive and really fast to get started with. You can choose to make a new project. You can choose if you want a web component or an application. You can choose some like predefined testing and linting environments. The web test runner is like one of my favorite ways to write tests nowadays. It runs tests on 3 headless browsers, making it so you can test on Safari, Firefox, and Chrome at the same time without having to do any extra setup yourself. There's also, you can create a storybook out of your components, so you can get started with your component library with just initializer, and you get a building setup rollup. It was previously Webpack, but anybody who has had to configure Webpack knows why they changed it. We could also go with TypeScript, but because I was selling web components with like, you don't need a build step, we're going to be skipping TypeScript for today. And we're going to be creating an application called Turku Frontend Scoreboard, for example. We will be writing some files on the disk and make a quick npm install. And even with a Quest Wi-Fi, it should be pretty fast. It's a good time for a drink. And we see it's already scaffolded the whole project. And if we move to the folder itself, we will see that we have a small starter project for ourselves. And if we just run npm start, we will see our, let's see. I'm in a wrong folder. Sorry about that. That was a complete folder. Yes, let's see. And scoreboard and npm start here. Yes. Now we don't have a complete application already. You had some spoilers there, but let's just ignore it. Just wipe it out of your minds for now. And let's go into the editor itself. If we look into the package.json, the initializer really isn't all that large. The only dependency we have is Lyyti itself. And the only dev dependencies we have is a analyzer for our custom elements, which is basically just for tooling. And then we have our web dev server, which only thing it does in this environment is serves our files and resolves our dependencies. It doesn't do any building at all. It just serves our files as is and resolves our dependencies as is. And if we look into the inspector itself, we will notice that we have our first web component on the view. The way you can notice a web component in the wild is the way you can see a web component in the wild is that it's just a regular HTML component separated by hyphens. There's a spec that you cannot make one-word web components because then you could maybe be like spoofing some existing HTML tags and be like, oh yeah, totally there's a fart HTML tag and it just farts when you scrolls. It's like there's a limitation that you have to have at least one dash in the name, and usually it's like good to have dashes in the name because if you just name your component, it's not gonna be good. It's like you have a submit button or something. You always have a place to fit the hyphen in. But let's look at the actual component here. In normal web component conditions, the components are built on class-based component. There's some libraries that are doing hook-based web components, but with the way that you do web components, it's usually better to have a class-based web component. And I'm gonna just move the styles here to the bottom so we can actually see the meat of the component. And there's a few parts that's in the component. There's the properties, there's just the initializing constructor, and then there's the render. The properties is a field of the Lyyti element library's component library system itself, and it's just used to declare your reactive properties. So any property that you want to trigger a update on your DOM when you change it. For example, we can see here that it's the title property, and we can see that the title is initialized as my app here. And if we just change this to Turku Frontend, it's of course going to reload the, let's see, bindings are goofed. Yes. And it's going to be updating the page, and it's going to show that the title is shown there. And I'll just remove some of the boilerplate here too, since it's just cluttering the view. The render function is another function that's used by the Lyyti component library. The Lyyti component library is pretty much the de facto way of creating web components nowadays, because it's really lightweight and it really makes it easier for you to create like dynamic components and having like actually good developer experiences and user experiences as well. And the component libraries I showed you before, for example, the Adobe one is already using Lyyti element as their base. So it's being used as a base library for a lot of component systems, even big companies. So a lot of people have decided not to create their own due to that. And if we look at the render function, it's just a regular render function you might see in, for example, a React application. But it returns instead of writing the HTML in JSX, because JSX needs building or parsing, we are going to be just returning a HTML template literal. So anybody who has written template literals knows that basically the HTML word here before the backticks here means that the HTML is a function that gets the contents of these backticks as its parameters, and it can parse through it and add like programmatic features into it. And we see one of the things that it's doing here is it gets the logo and the title dynamically on the page. And the great thing about Lyyti and why it's so popular is that it doesn't have to do any large diffing on the whole component when it does updates on it. It always marks the positions on the DOM that actually need to be changed, and it only changes the dynamic parts on the component when it needs to do it. So some earlier libraries that have been created might have like re-rendered the whole component every time a property changes, and that's like really ineffective. And then there's popular libraries nowadays which do like diffing on the DOM or in the virtual DOM, and that can also get quite expensive in the end. So what Lyyti does, it just compares the dynamic parts and it compares them straight on the DOM itself. And if we were to modify it, so if we just because web components are just regular components on the page, we can find the component with any browser function that is existing. We can use just a regular query selector and we will find the component there. And if we change the subject and update it, it will instantly update on the DOM. So it's blazingly fast and it's really fun, really easy to use because it already builds upon the existing like browser standards and the existing systems on the page. You don't have to be finding your like dynamically created classes to bind something, or you don't have to have an ID because the component's name itself works as an ID here. So you are really like making it a lighter experience on the web page and also for the developer itself. But on to the actual demo here. We are creating a scoreboard with the projects. And to create a new custom element, you can just like define it on your page anywhere. I could even go into the index.html and just define it here. It doesn't need to be on JavaScript. It can just be HTML itself. And we can create our component onto the page, and we can see that it's not throwing any errors because it's completely viable HTML on the page. There's nothing wrong with the actual tag here. It's just that like the browsers are not built to understand what this tag is supposed to do when it's on the web page. But to do that, we will create a new file. And let's see, we are going to be calling it scoreboard.js. So web components, the only like big requirement of web components is that you have JavaScript on your page. So if you are creating experiences for somebody who's not using JavaScript, well, good luck nowadays. And the first part of creating a web component is just creating a class with a unique name and that extends the lit element base class. If you are creating without a library, you could be extending the HTML element and just writing all the logic yourself. But since we're using lit element, this is the only setup we need, and we can just do a quick hello world to make sure that our component is visible. And it's not visible yet because we have not told the library how to handle the custom component. And that's the last part of defining a new component. That's just defining the component itself. So we named it scoreboard, and we tell it like, yeah, just go into the scoreboard class and look what it does, and there's your implementation. And as soon as we let's refresh that. As soon as we save, we should be seeing our, let's see. Let's get that demo effect, or it's, yeah, sure. I'm not using types here, so I'm kind of lost with the imports. Yeah, thanks for that. We found the only web component developer in the house today. So we now see immediately that our component is on the page, and we didn't get any errors that were related to the component itself. The only error we got during the whole process was just that import scoreboard was missing because we didn't create the file where we create the import. And this is the only setup you need to get a functioning rendering component on your page, and this is the bare minimum that you need to do. Next up, we are going to be creating our actual scoreboard, and to create that, we need to initialize our scores. We're creating just an array, and we are creating some players into our scoreboard here, and giving them a random amount of points. Totally random. Let's see. And the last one. And yes. And since we want this scores property to be dynamic, we have to tell lit element that it's a property of this class. And that's done with the property getter we saw already in here. So it's just a static getter that returns a JSON object with the key being the key of the object, so here scores. And then we give it some extra information, for example, with it's type array. In JavaScript, it doesn't really, in JavaScript, types don't really matter. But here it tells lit element to observe certain types of changes on the object. And if we want to render it onto our view, it's as easy as with any other web component library. So we can just go into our scores and map through them. For those who don't know what map does, it takes a array and returns another array that has some kind of a operation applied to it. And in here, we are just generating a HTML template literal for each of our scores. And inside the literal, we are just creating a list tag. And inside the list tag, we are just putting the entry.name hyphen entry.points. And if we just update the page, we already see that we have a list rendering on the page, and it didn't really take any heavy lifting. And some of you might be realizing here, but you returned an array. It shouldn't be an array on the DOM, just this stratified array. But that's where the power of lit element comes, because no matter how many nested HTML template literals you pass into the render function, you will always get all of them recursively executed, and they will always appear on the page as you might expect them to appear. And show that the data, to showcase some of the effectiveness of the library we are using, I will be adding some randomized scores here. So we will be creating a new score, and we will be assigning it a random amount of points. Let's time it by 100. And every time we call the items function, we will get more scores on the page. And that's where we will be needing a button to add the scores. And this is where the templating of lit comes in, like big time. In like regular HTML components, you have to get the reference to your component and add the event listeners yourself by hand. But here you can just use, if you've ever used Vue, this is really familiar to you. You just add a sign before the event name, and it already knows where to add the event listener. And now, every time we click on the add button, we will get a new entry onto our entries, and it gets updated in real time onto the DOM. And if we just look at the DOM itself, if you were to write this by hand, you would maybe be re-rendering the whole lit because that's just so much easier. But when you are doing it with lit, it only updates the newest element onto the page itself. So it doesn't need to do any kind of like re-rendering of the other elements because they have never changed. They are the exact same elements on the page. And to showcase this even more, we are going to sort the scores after we have added the score. So we are going to be just sorting the scores by the score points. And if I got it right, we should be having the points in the actual order of like points on the page. And if we again look at the DOM here, we will see that the only element that actually got like updated on the DOM is the bottom one. Because as I said before, lit creates these markers for the dynamic content itself. It knows that here's the dynamic content you need to update. And when you update it, it just goes in there and almost surgically applies the changes straight into the DOM itself, instead of like re-rendering the whole list element because something changed inside it. So that's something that has created really, that's making like web development really easy, because you can create these experiences on the web without having like a heavy library to weigh you down. For example, if we went to bundle phobia, which shows you the size of packages, you will see that it's not really going to be slowing your application down if you add lit element or lit into your project. It's under 7 kilobytes minified, and it gives you all of these superpowers to create components on your web. And since you are developing on web standards, it's not going to be like that the next npm install is going to break your application, because web components are not going to be changing anytime soon. And Lyyti is also pretty slow to like break anything. So if you are choosing to use lit element as your web component creation tool, it's going to be beneficial for you. I don't know if I'm going overtime here, so I'm going to be stopping the demo here. Okay, well, I'm going to be demoing a bit more, because now we have just created a web component inside of a web component, but to actually like power through the fact that you can create components on the page and they act like regular HTML, we are going to change the scoreboard items from a list item to an actual web component. And we're going to do the same kind of boilerplate setup here. We're going to import lit element. We're going to be creating a render function. We're going to this time import the HTML2. If this was TypeScript, my editor would know to import it or tell me if it's not imported, but let's not go into TypeScript today. Let's see. We are going to be defining our web components. So if we use the HTML tag scoreboard item, we will get the functionality of this class, like we saw before. And we're going to be making it so it functions like the list item itself. So it's going to be taking two parameters. It's going to be taking the name of the person on the scoreboard. Yeah, thanks for that. And then it's going to be taking the score point itself. We're going to tell it the points are numbers because we're not animals here. We're not using points as strings. And then we're going to just render them like you would do with like regular JavaScript templating. And if you go here, we just import our scoreboard item. And if we change it here, the only thing we need to change is this line. So we can just go scoreboard item, name is entry name, and points is, let's see, entry.points. And since we're not with JSX, there's a small cumbersome thing that you need to do. Like even if you don't have anything inside of your component here, we have like no content inside of our component, we still need to use the closing tag because the HTML standard for some reason doesn't like if you don't use the closing tag. Like self-closing elements are like there's image element and input element that's self-closing, but there's many of them in the world in like the actual browsers built in. But as we created these, we are seeing that our list items are a bit wonky. That can be changed with a little bit of styling. With Lit, you can also get styling up, out of the box. And styling is created the same way properties are created. You create a static getter. You tell it to use the CSS template literal instead of the HTML template literal. And inside here, instead of using selector scoreboard item, which would work, we are using a special selector only usable in web components or like Shadow DOM context, which is host. And it just tells to style the actual element that we are currently attached to. And we can say that this is like, yeah, this is totally a list item. Just believe me over here. And UL that's on this page, well, there's no UL here, but the HTML will just like act like it's a list item and we can get the functionality here. And we can get some neat inbuilt functionality onto the page. For example, since CSS knows where it is on the page, we can tell that the top tree of our scoreboard has the certain colors, brown because bronze is not a color. We have a listing that updates dynamically because it's purely CSS. There's no JavaScript powering these changes, so I'm just like, this kind of technology makes it really easy to create like lightweight experiences because most of the things we are doing on the page is just like regular web standard stuff. We are creating HTML elements on the page. We're just rendering some HTML onto the page, and we are using CSS to style content on the page. If we, however, for example, want to create something conditional and actually have some JavaScript here, we could give the first place player a crown, for example. And that could be done by just having a property called first place. And then we could just go onto the rendering and be like, if this is first place, we will be rendering a, let's see, crown emoji. Totally have a emoji keyboard on this system, but I don't know how to use it, so let's not risk it on the live stream. But if we do that, and then we tell it that like, okay, we are passing these as attributes, but if we want to like pass a Boolean attribute, it can't be really like camel case or Pascal case, because HTML attributes are separated by a hyphen themselves, because everything in XML and HTML is separated by a hyphen, because that's how it works. Everything is lower. Just tell it to observe some kind of a attribute. So if we give it a attribute first place, it will tell to map the property first place from the attribute first dash place to the first place here. And if we went to here and just told it that it's first place, if the I is 0, we will see that Juli's got a crown on the scoreboard, and the crown even like is updated dynamically to the score that's actually at the top at that moment. Accessibility aside, it's not really readable on the screen, but this crown and the name is there anyways. And here is also an example of how lit templating really makes it easy to give you attributes, because sometimes you just want to give an attribute without a content itself. And those are called Boolean attributes. I can promise any one of you has used Boolean attributes before. When you create an input and you make it required, you're not like required equals true. It's just required. And that's called a Boolean attribute. and those can be mapped really easily with the lit templating by using just a question mark and telling it the like actual like check to make sure if the Boolean attribute is on the page or not. I'm not going to be demoing anymore because I want to have some room for the questions and some room for the rest of the pizza there. So let's end it here. If there's questions, I would be glad to answer them and maybe show if there's something you want to see from the back. Yeah, so there was a question, how could you like implement a component I have created and how you could customize it and make it look like your own and act like your own, right? That was the question. Well, if you want to add some like functionality in JavaScript, since it's a JavaScript class, you can just extend it and add the functionality yourself in there. And just like you can extend the component and create a new class for it and add the functionality there. But if you want to, for example, style it to look like your own, since our scoreboard is inside of our Turku Frontend scoreboard, we can it's just HTML. It's just HTML. So you can just style it like you would do with any other. Yeah, let's see. We don't have a display flex on it, so it's not showing. But you can style it just like any other HTML you would see on the web. And it just styled as you would like for it to get styled. But for the JavaScript part, you would like, if I want to take the scoreboard item and extend it, I would create a class foo extends scoreboard item. And I could then just go ahead and overwrite the render function and make it render something I want it to render. So I could make it so it's like it's a p tag instead of a no tag at all. So you can just X class and customize it yourself there. I hope that answered the whole question. Yeah. Yeah. Of course. The question was if there's a possibility to separate the styles from the component itself or use some kind of CSS preprocessors, for example, less or SAS or anything like that. Well, since this is just a static getter for styles, I could just put it here. I could just state it's here. And it could be equal to the CSS here. I could put it into any file since it's just a getter that returns some CSS. The function also allows you to use an array of CSS, so you could apply base styles. You have a library that has like core styles of your design system. It has the CSS variables and everything, and then you could just add that to your styling here. You could like be core styles, and it just gets extended there, and you could use it as you would use it anywhere. And what comes to the preprocessors, you could use a building system that generates a separate file that has the like styling built inside the CSS tags, and there's like, for example, playground element. We have just a plain CSS file that gets bundled inside, which contents get bundled inside one of the CSS template literals, and then the bundled CSS gets imported into our element, and it just works with the styles that are bundled using, I think it's SAS at that point. That's a question for another time. Right? There was a question if the creators of web components were. Could you please repeat? I kind of. Oh yeah, if like instead of putting it all into HTML, they would use XML or any other format like that allows this kind of tagging. Yeah, I don't think they really considered that because web components were pretty much built for the HTML engine on the web, so it was built to work like HTML tags. So there was no need to move to any other technologies at that point. But I wasn't there when it was created, so I can say for sure. And there.
Yeah, you said the class class system was easier to use with components rather than hook-based system. So elaborate on why that is.
I just think it's because so class-based systems versus hook-based systems. I said before that class-based systems are just easier with web components, and why that is. Well, the first thing is that the actual web standard is built on class-based systems. So it's like from the get-go we are working with classes, and when you are working with classes, you usually are working with stateful processes. When you have a web page and a web component, we have a lot of state with it. We could, of course, create a functional environment like you would do with hooks, but a lot of authors have opted to use components like class-based systems because they are able to extend the existing APIs that are built onto the browsers itself, and also because a lot of the times there's some kind of state coming with the elements itself. So it's a lot easier for a lot of people to understand. I think that's one of the main points too. But as I said before, there are some implementations which are using hook-based implementations for this, and they function quite well. But in the end, under all the matrices and everything, there's always the HTML element class that they are using to create the custom element onto the page, because they can't create it with extended HTML element base class. Yes.
So what about with React, creating props down or having context or whatever, global state handlers? What would be the mechanism with an application that's built fully out of custom elements?
Yeah. The question was, since in React, for example, I have you can drill your props downwards on the DOM tree, and you can have context APIs and global state. How would you be implementing that on web components, and how would you work with that? The first thing, if we went to the example property bindings, we are only working with attributes here, which limits it to only string-based data. For example, if we tried to pass the entry as a JSON object, it wouldn't work. But we can, I can just show you here, but it's not going to be compiling. But we could be passing the entry as just an attribute, and here we see that it's not working. And if we look in the DOM, it's just because it's object. Everybody's nightmare. Because when you go into the HTML DOM, everything is string and everything is turned into a string. But with just a single character, you just add a period before it, and it gets passed down onto the element. And if we were to replace these with a entry that's type of object, and then be like, okay, this is this entry name and these entry points. Boom, we have thing functioning again. So drilling props is really easy. You just the period notation is okay, scoreboard item dot entry equals to entry. So it's really intuitive to use those, and it really gives you the ease of use, because if you were to write this yourself, it's going to be a pain, because you have to have the reference of the element, you have to have the data, and you have to bind it yourselves. And what comes to the global context APIs and those, well, if you're working with vanilla, there's you have everything that's provided by the browser, but that's pretty much it. But for example, with Lyyti element, there's multiple supporting libraries that are built on top of Lyyti element, or to utilize the power of Lyyti element to provide, for example, global state variables and global state actions. For example, lit mobx, mobx maybe, is something that was used by the Adobe team, and it's created by the Adobe team. They were using this to handle their state globally on the Photoshop build, and there's a million other state management systems there that are handling global state between components. And also, you could just like do it yourself, because since we are working with the browser itself, we should be utilizing the browser's capabilities, and the browser's event API is such a powerful beast that you should look into using it, and you should look into how you could like utilize it in this kind of context. Because with custom elements, one of the APIs that it really uses well is custom event APIs. You can create your own events, you can bubble your own data to anywhere on the web page as long as you're in the same like context. So you can like go cross-boundary from iframes or anything, but you can really create any kinds of global states through events and event systems. I hope that answered enough. And there's a question. Yeah. I think it's maybe easiest if I just show you a web component that's like not built with Lit. So let's see. There's a, for example, here we can find a web component. Let's see, lib, content is the crawler, somewhere over here, and there's the spotlight. So with a normal web component system, yeah. Yeah, this was the one I had in the slide because this is just so boilerplate that it's not even funny. In the like normal web component API, one of the parts is the template API. The template HTML tag allows you to create a part of HTML and CSS that's not like processed by the browser at runtime. It's processed only when it's instantiated, so it's just waiting for you to use it somewhere. And you just define that. Then you have to create the constructor, have to create the shadow root yourself, or you have to create your encapsulation yourself with the shadow root comments. You have to append the contents of the template. You have to clone it and append it into your page. Then you have to create like the whole updating functionality yourself. Nothing out of that comes out of box. You have to create the reactivity for your attributes and properties separately. Nothing comes out of the box. So pretty much nothing except the constructor and the custom element definition at the bottom is part of the normal workflow of building a web component. That's why Lit element is like so popular, because it's like getting the thing out of your hands and doing it for you, because nobody wants to do this like for the 100th time. And we are critical on the band, we are critical on time, so if there's no more question, there's one more question. Yeah, that is true. So there's a question about the fact that I'm saying that web components are not going away, but I'm using a library that might be going away because it's put by Google, so it could be just axed someday. But yeah, the reason I'm not doing a live demo on like building a vanilla web component is because it would just take too much time, and I could use a base class to like ease that into it, but I'm trying to like think of the points in the question, but the reason that web components are here to stay, like I said before, is that because they're based on web standards, but libraries are not they're not dependent on web standards. So I said in my talk, web components should be here to stay, but whether or not you should be using a library or not is something you should consider. Because, well, even if you created a web component with Lit, you are already using technology that's here to stay. So if the library gets pulled out from under you, you could still transition without changing the whole tech. So your rendering system is the same because it's just HTML rendering, and your thought patterns are worked around the web component system. So you are like thinking about like what can I use as an attribute and how can I utilize attributes with CSS. So a lot of the like systems that you are doing, or like a lot of the work we are doing with Lit is completely translatable to vanilla web components. But the reason I did the demo with Lyyti is because Lyyti is like the easiest way to get into the development of web components. I myself advocate to use Lyyti if you want to get something done, and use vanilla web components if you want to like make something last for the next 20 years or something.
So a couple of last words. First of all, thanks to Matias and Huhta for great talks. Thank to Lyyti for being the first one to host us. And especially Dusan for kind of pushing this. That hey, now it's time to get back. Let's do this. Speaking of future meetups, next one will be on November 24th, which is the last Wednesday of November. We will be at Conders, and we will have 2 talks about web accessibility. So we will have a themed meetup. And then the last one of the year is gonna be on 15th of December at Vincent. And if there's anybody who wants to give a talk on that one, we still have open slots. So feel free to come to talk to me. And then we have the last words by Lyyti.
Thanks. Hey, big round of applause again to our speakers and Juhis for taking care of the live stream. I want to keep it short because I see you're all excited to go write some web components after this. So basically, there's still a lot of bottles and cans in the fridge. Please help us empty them before tomorrow morning. So no need to leave here. We're fine staying here. I think me and Dusan will anyway be the last ones. That's a typical one. And if for some reason we run out of drinks, there's some nearby bars or stuff we can go to. It's nice having you here. Nice seeing so many people in the office. Thanks.